So imagine this for a second. You tell your phone, hey, book me a flight, get me a hotel for that conference. And bang, an AI just sorts it all out.
Yeah, and not just sorts it, but maybe even, like, negotiates a better rate than you'd even think possible.
Exactly. And it does it all by itself.
Yeah.
Well, that's not science fiction anymore, right?
Yeah.
It's where AI agents are heading, and that's what we're diving into today.
Precisely. And what's really interesting is this isn't just theory. We're seeing these intelligent acting systems already making an impact.
So this deep dive is all about AI agents, what they actually are, how they tick, and I guess why understanding them is becoming so important for, well, for you listening.
Right. We've looked at some material that tries to explain it simply using examples you can actually relate to.
Okay, good. Let's jump in then. What is an AI agent in, plain English?
Well, think of it like a computer program that has some initiative. It can sense its environment,
Okay.
process that information to make decisions, and then actually act in that environment to hit specific goals.
So the key is it's not just like crunching numbers.
Mm-hmm.
It's deciding and doing things.
Exactly. It's got that autonomy to act based on its decisions.
Give us a really concrete example, something we can picture.
Okay, think about a self-driving car. All its sensors, the cameras, the LiDAR, GPS, it's perceiving the world.
Right, taking it all in.
Then, based on all that incoming data, its internal system decides, okay, speed up or brake or change lanes. That's the decision part.
The action is.
The car physically doing it, steering, accelerating, braking. It's this constant loop. Perceive, decide, act. That's how it gets you where you're going.
Perceive, decide, act. Okay, I get the loop. It's a cycle.
Exactly. That's the fundamental engine behind every AI agent, no matter how simple or, complex it might be.
Let's unpack that loop a bit more. Perception, what kinds of inputs are we talking about? Is it just cameras?
Oh, it's much broader. Perception is just how the agent gets data from its environment using sensors. So yeah, cameras and LiDAR for a car,
Mm-hmm.
but a microphone for your smart speaker, or even live financial data feeds for a trading AI. Anything that brings information in from the outside world.
Okay, so it's pulling in all this raw information. Then the decision phase,
Yeah.
what's happening there?
That's the processing stage. The agent uses logic or maybe machine learning algorithms, think of those as complex recipes, to figure out the best action to take based on the info it just got and what its goal is.
So it's the thinking part.
Pretty much, yeah. It could be simple rules like if temperature drops below X, turn on heat, or something much more sophisticated involving prediction and learning.
And action seems straightforward enough. It does the thing it decided on.
That's right. The action is how the agent interacts back with the world. Moving a robot arm, sending an email, showing you search results, adjusting a thermostat. It's the output.
The robot vacuum cleaner example really clicks here.
Ah, yes.
It senses the dirt, right? That's perception. Decides, go clean there, that's decision. And then it physically moves and vacuums. That's the action, is doing that loop constantly.
That is a perfect everyday example. It uses its sensors to see the room and dirt. Its programming decides where to go, and its motors and vacuum carry out the action, a continuous cycle.
Okay, the basic loop makes sense now. But like you said, there are simple ones and complex ones. That vacuum is way simpler than a self-driving car. So are there different categories?
Absolutely. They vary a lot. We can generally sort them into about 5 main types, kind of building up in complexity.
Okay, let's break them down. What's the simplest type?
That would be the simple reflex agent. It basically just reacts to what it perceives right now. No memory, just stimulus response. Think of a thermostat.
Right. Senses too cold, action turn on heat. Senses warm enough, action turn off.
Exactly. Purely based on the current input.
Okay, what's next?
Then you have model-based reflex agents. These are smarter because they maintain an internal model or representation of the world, like a little map in their head.
So they remember things.
Sort of. They track how the world changes based on their actions or just over time. This helps them make better decisions than just reacting. Our robot vacuum that maps your room, that's likely using a model.
Okay, so it knows where it's already been, for instance. Got it. What's level 3?
Goal-based agents. Now we're talking about agents that have a specific objective they're trying to achieve. They choose actions that they predict will lead them closer to that goal.
Like an AI playing chess. Its goal is checkmate.
Perfect example. Every move it considers is evaluated based on whether it moves it closer to winning the game.
Right, okay, moving up again.
We get to utility-based agents. These are more sophisticated. They don't just have a goal. They try to achieve it in the best way possible according to some measure of utility or desirability.
How so?
Well, imagine a delivery drone. The goal is deliver the package. But a utility-based drone might weigh factors like speed versus battery life versus maybe avoiding a risky storm. It chooses the action that maximizes its overall happiness or utility score, not just the quickest path.
Ah, I see. It's making trade-offs for an optimal outcome. And the final type.
The top level is learning agents. These agents can actually improve their own performance over time. They learn from experience.
How do they do that?
They usually have a learning element that analyzes feedback on their actions. Did this work well? Did it fail? And then modifies their decision-making process for the future. Personal assistants like ChatGPT or others that get better at understanding you, they are learning agents.
So they adapt and get smarter. Okay, that progression makes sense. Now, another term we hear is autonomous versus semi-autonomous. What's the deal there?
It really comes down to independence. How much human input do they need?
Okay.
Autonomous agents are designed to operate completely on their own once they're set up and given a task. Think of that Mars rover exploring Mars.
Right. No one's joysticking it from Earth in real time.
Exactly. It's making its own decisions based on its programming and sensor readings millions of miles away. That's autonomy.
So semi-autonomous must mean they work with humans.
Precisely. Semi-autonomous agents handle certain tasks but still rely on human oversight or collaboration. Airplane autopilots are a classic example.
The pilots are still there.
Right. The system flies the plane under certain conditions, but the pilots monitor and can take over anytime. Customer service chatbots that escalate tricky questions to a human agent. Also semi-autonomous.
So thinking about it, most of the AI agents we probably interact with day to day fall into that category.
That's absolutely correct. The vast majority right now are more like tech co-pilots. They augment what we do rather than replace us entirely.
Okay, great. So we know what they are, the different types. Let's talk about where we actually see them. What are some big real-world use cases right now?
Oh, they're becoming quite widespread. Your virtual assistants, Siri, Alexa, Google Assistant, those are AI agents managing tasks, answering questions, controlling smart devices.
Yeah, use mine all the time.
Then you've got customer service chatbots popping up on websites everywhere, providing instant answers.
Sometimes helpful, sometimes less so.
True. They're still evolving. But think about games, too. Those non-player characters, the NPCs, the smarter ones that react to how you play. They're driven by AI agents.
Right. Some of them are surprisingly clever now. What else?
Well, we keep coming back to self-driving cars, a huge area, but also smart farming. Agents monitoring soil, weather, automating irrigation. It's making agriculture more efficient.
That's interesting. Agriculture.
And finance. Huge applications there. Detecting fraudulent transactions, running algorithmic trading strategies based on market data. Agents are processing vast amounts of information incredibly quickly.
Wow, it really is touching almost everything.
Yeah.
And our sources mentioned some specific examples emerging in Africa too, right?
Yes, which is really exciting. Seeing AI tailored to local contexts. For instance, in Kenya, there are AI tools being developed to give farmers very specific advice based on their local conditions.
Helping optimize crops.
Exactly. And also building chatbots that can communicate in local African languages, which is massive for accessibility of information and services.
That language aspect is crucial.
Yeah.
Okay, so we mentioned learning agents. How exactly do they learn? You said feedback, but how does that work mechanism-wise?
A really important technique is called reinforcement learning.
Okay.
The basic idea is learning by trial and error, guided by rewards, like training a pet in a way.
Go on.
The agent tries an action in its environment. If that action leads to a good outcome, something that gets it closer to its goal, it gets a reward signal.
Like a virtual biscuit?
Sort of.
Yeah.
And if the action leads to a bad outcome or no progress, it gets no reward, or maybe even a negative one, a penalty.
Okay.
So over many, many trials, the agent learns to prefer actions that lead to rewards and avoid actions that lead to penalties or nothing. It literally reinforces the successful strategies.
Can you give an example?
Think about teaching an AI to play a video game it's never seen before. At first, it just presses buttons randomly, right? It does terribly. But maybe accidentally, it makes a move that gets points. Reward. Its internal programming tweaks slightly to make that kind of move slightly more likely next time. It makes a move that causes it to lose a life. Penalty. It tweaks to make that move less likely.
And after millions of attempts.
Exactly. After potentially millions or billions of attempts, playing against itself or other versions, it can figure out incredibly complex strategies and become better than any human player. We see this with game AI, but also with robots learning to walk or manipulate objects. They literally stumble around until they figure out the sequence of movements that works.
Wow, trial and error on a massive scale. Okay, that makes sense. But this increasing sophistication, it must raise some challenges or ethical questions.
Oh, absolutely. That's a huge part of the conversation, and rightly so. One major issue is bias.
How so?
Well, if the data used to train an AI agent reflects existing societal biases like historical loan application data, for example, the agent might learn to replicate those biases, leading to unfair or discriminatory decisions.
So, garbage in, garbage out, but with potentially serious consequences.
Precisely. Then there's privacy. These agents, especially personal assistants, often need access to a lot of personal data to function effectively. Where does that data go? How is it used? Who controls it? Big questions.
Yeah, definitely. What else?
There's the potential for harmful actions, even unintentional ones. An autonomous system making a mistake in a critical situation, or a chatbot giving dangerously wrong medical advice because it misinterpreted something.
Right, the stakes can be very high.
And also the broader societal impact of over-reliance on automation. What does it mean for jobs, for human skills, for our own decision-making capabilities if we constantly delegate to AI?
These are really significant considerations we need to grapple with as the tech develops.
Without a doubt, ethical development and deployment are crucial.
So looking ahead then, what does the future hold for AI agents? Where are things heading?
The general trajectory seems to be towards agents becoming more capable, more integrated, and potentially managing more complex systems, not just single tasks. Imagine agents coordinating citywide traffic flow, or managing energy grids dynamically, or even collaborating with scientists on research projects. We might see them moving beyond execution to more strategic oversight and even creative partnership.
And thinking specifically about the African context again, building on those current examples.
The potential there is immense. Think about real-time translation agents breaking down language barriers across the continent instantly.
Wow, that would be transformative.
Or AI tutors reaching students in remote areas with personalized education. Or those farming advisors becoming even more sophisticated, helping ensure food security. The potential to leapfrog certain infrastructural challenges using AI agents is really significant.
It really sounds like these agents can become powerful tools for empowerment and development.
That's definitely the hope and the potential we're seeing. It's not just about automation, it's about enabling new capabilities.
A really exciting, if slightly daunting, future. AI agents are clearly not just coming, they're here and evolving rapidly.
They really are, reshaping our world in ways we're only beginning to fully understand.
So to you, our listener, now that you've got this deeper picture of AI agents, their capabilities, their potential, what comes to mind for you? What kind of tool or application could you imagine building with them?
It's a fascinating question to ponder, isn't it?
It really is. Hey, if this deep dive sparked some ideas or just made things clearer, do hit that like button for us.
And definitely subscribe if you want to join us for more explorations into tech and how it's changing things.
Absolutely. And please, share your thoughts. What could you create with an AI agent? Drop your ideas in the comments below. We'd genuinely love to see them.